In this session, we're going to prove one of the most important theorems in differential calculus, the chain rule. And it's used widely throughout. Many of the problems that you work on are going to employ the chain rule. And the chain rule states the derivative with respect to x of the composition f of g of x equals the derivative of x evaluated at g times the derivative of g. To work out this proof, we're going to use a slightly different method than we've used in the past. We're going to use the alternative form of the derivative to solve this. And the alternative form is going to give us the limit as x approaches c of the quantity f of g of x minus f of g of some constant c over x minus c. Now, as we go through this, there's going to be an underlying caveat here that we're going to have to make, because there is an issue with the value of g of x as x approaches c. So we're going to make a distinction here in a second that's going to handle that. There's a more general proof, but for most cases this proof will suffice us. So now we're going to have to employ another algebraic technique to get moving further. And in the past, what we've done is we've added and subtracted the same quantity to the terms in the expression. What we're going to do in this time is we're going to divide and multiply by the same term, thereby multiplying this whole expression by a form of 1, which doesn't change the expression, but it alters the way the expression looks. And we're going to do this again for grouping purposes. So what we're going to do is we're going to take the limit as x approaches c of f of g of x minus f of g of c all over x minus c times a brand new set of quantities, g of x minus g of c over g of x minus g of c. Now, the caveat that we're going to add in here is that g of x doesn't equal g of c. As you can see, that creates a problem in this sequence. So continuing on, what we're going to do at this point, because this is all multiplication and division is commutative here, we're going to take this, we're going to slide it over into this place, and we're going to take this and move it over here, because that gives us a special feature here. So let's go ahead and do f of g of x minus f of g of c over this quantity, g of x minus g of c, times, and then we're going to have this quantity over this quantity. So we have g of x minus g of c over x minus c. And we're taking the limit as x approaches c of this whole quantity. Now, this becomes a derivative. The limit as x approaches c of f of x, g of x, f of g of x minus f of g of c over g of x minus g of c is f prime of g of c. And this quantity, with the limit as x approaches c of this quantity, becomes g prime of c. And so, in the more general case, then we can say that this is f prime of g of x, g prime of x. And that's the chain rule with our special consideration. If we take into consideration the continuity of f and g, we can eliminate this, but the proof is a little bit more complicated and involved, and as I said before, this handles most of our cases. So we just live with this consequence and move on. And that is the proof of the chain rule for differentiation. And I'll see you in the next session.